Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 1st, 2025, just 3 days ago. The standout result is a unified, modular framework that enables agentic reinforcement learning with tools and delivers near 2 times rollout speedups through asynchronous execution. The paper is titled VerlTool, Towards Holistic Agentic Reinforcement Learning with Tool Use, and the implications for model training are quite significant. Beyond speed, the framework standardizes tool use across code, search, SQL, and vision, and matches specialized systems across 6 domains while reducing development overhead. Also, the author shared an implementation on GitHub. You will find a full training and evaluation framework built on Verl, examples and benchmarks, an async rollout design, a tool server, NL2, SQL and DAPO recipes, scripts, requirements, and a detailed README with quick start, training guides, and design docs. Alright, Figure 1 conveys the core idea. The training loop and the tool execution run as separate modules, so agents can act and learn while tools operate independently. The figure shows a Verl workflow that drives multi-turn rollouts and policy updates, which hand off tool-invoking actions through a unified application programming interface. A tool server routes those requests to plugins like Python, Web Search, SQL, or Vision, then streams observations back. This decoupling enables asynchronous rollouts, reducing idle time and boosting throughput. So Table 1 makes the practical point that unified tool coverage is the differentiator, because agents need consistent access to search, code, SQL, bash, and images. The table compares major training frameworks and shows that only VerlTool checks all these columns. Most alternatives miss Web Search or executors, which limits multi-turn tasks. This matters for researchers, since broad tool support shortens setup time and enables fair head-to-head evaluations across domains. Figure 2 shows how asynchronous rollouts eliminate idle bubbles, so GPUs stay busy and throughput rises. The top row illustrates the synchronous case, where tool calls force everyone to wait, which creates the dashed idle gaps. The bottom row illustrates the asynchronous design, where each trajectory proceeds independently and save time accumulates as green blocks. Model response, tool calling, and policy updating interleave smoothly, which shortens wall clock rollout time. So, Table 3 quantifies the payoff. Asynchronous rollouts cut wall clock time, because each trajectory proceeds without waiting for others. The table shows latency in seconds for math, TIR, SQL, and deep search, with 1 turn setting per task. Sync times are higher, while async drops them, which yields speedups up to about 2 times. The headline number is 1.97 for deep search, and the other 2 tasks still gain meaningfully. Alright, 2 takeaways stand out. A single modular stack standardizes tool use across code, search, SQL, Vision, and more, and asynchronous rollouts nearly double throughput without sacrificing performance. The broader implication is faster, fairer experimentation for multi-turn agents, which should accelerate research and deployment. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.